Zamrez, can you hear me? Zamrez, are you there? Can we start?
Yes.
Okay. So first we'll start with a normal phenomena of acidity that we usually encounter. It is one of the application of acid. What happens in your stomach? You already know that we have HCl, right? We have HCl in our body.
Yeah.
Okay. Now, what does this HCl do?
It breaks down the food and food we eat.
So it helps in digestion, right?
Mhm.
Zamriz, you have to
Yes.
speak because I cannot see you.
Yes.
Yes. Okay.
Okay.
So now the thing is, when it helps in digestion, so it is a kind of a very, very strong acid that you have already known of. So sometimes what happens due to indigestion, this acid can come in the esophagus and can cause the chest burns. You know what's the esophagus, the food pipe? So sometimes what happens that this acid can rise up in the esophagus and can cause a chest burn, which is very, very harmful.
Mhm.
Okay. So one of the implication of acid in our body is it causes acidity or chest burns. Clear? Now moving on to the second implication, just a second. Moving on to the second implication is acid rain. Now, for this, we should blame the industries and the vehicles. What happens here? The factories emit a lot of mixed gases they release, right? These factories, vehicles, they release a lot of polluted gases, right? Now, one of the major ingredient of these gases is sulfur dioxide. Okay? Now, sulfur dioxide and nitrogen oxides, they are like poison. What does it do? It is going to react with the atmospheric humidity. Okay. And can produce a lot of acids. You can see in the picture, just a second, what you can see that sulfur dioxide, nitrogen oxides from the factories, they are, what are they doing? They're mixing with the atmosphere and cause formation of various kinds of acids. And that leads to the acid rain. First, acid clouds will be formed, leading to the formation of acid rain. If you have a litmus paper in your home, next time when it rains, if you take your litmus paper, if you allow the litmus paper to get wet in the raindrops, you will see that it changes its colors to the acid parameter, as per the acid parameters. Clear? Please note this point down. And note the pH. Acid rain's pH is 5.6. Okay. Now, it is write down acid from, so write down sulfur dioxide and nitrogen oxide, sulfur dioxide and nitrogen oxide arising from the fumes of, factories, reacts with the humid air of the atmosphere, leading to formation of sulfuric acid and nitric acid, which falls as acid rain. Done? Now, what are its effect? This rain is going to fall on the soil. So what will happen? The soil pH will change. Correct? If the pH of soil changes, it is going to affect the vegetation. Okay? Next, the same water is also going to fall on the water bodies, changing the pH of the water bodies. That helps, that allows, not that allows, that affects the marine life. Zamrez, pay attention. Okay? So just a second. Just a second. I'll take this. It's a very urgent call. I'll take this. Hmm. Yes. Moving on. What were we discussing?
Acid rain.
Yes, acid rain. So you have we have talked about two harmful effects of acid rain. First, it is going to change the pH of water. It is going to change the pH of soil, affecting the vegetation because it is going to change the pH of the soil. And when it changes the pH of the water bodies, it affects the marine life. Clear? You might have seen they in few years back, I don't know whether you are aware about this or not. There was a pond near in Uttar Pradesh. You know about Uttar Pradesh. It's a state, right? Now there of a jute factory was there, and around that one small pond was there. Okay. Now within one night, the dead fish were floating on the top of the pond. All the fishes died because of the chemicals that they release. Okay. Now moving on. You have heard of Taj Mahal, right? You know that the color of Taj Mahal has changed now. It was pearl white. When I saw Taj Mahal, it was pearl white. Okay. And now when I go and see, it has become yellowish. You know why? Because of acid. Acid, when it rains, it has acid, it has some acidic component. It is going to react with the marble and can cause a reaction. It is causing reaction and corroding the top layer. Okay, destroying the beauty of Taj Mahal. I just gave you one example. It is affecting the vintage monuments, the buildings a lot. Clear? Can we move into the next topic? Zamrez, no doubts from acid, right? Please take down your running notes. Let me know once you are done, then I'll enter into bases. Done?
Wow. Wow. Okay, it has become so yellowish.
It has become so yellowish, yes. So can we move into the next topic, Zamrez, if you have taken your running notes?
Mhm.
Done, right? Done? Done, Zamrez. Can we move? Say yes, no, something. I cannot hear you.
I was just wiping my oily pen.
You were writing the.
My pen was oily, and then okay, I'm done.
You're done. Chalo. Now moving on to bases. So this is quite opposite to acid. Acid was sour in taste, right? And bases are bitter in taste. Apart from that, we discussed one more property in the last class, is its soapy texture. Correct? So they have two basic properties. One is their bitter taste and the slippery texture that they have. Okay? And their chemical nature is basic. Clear? Okay. Do you know about the pH range, Zamrez? What is the neutral pH range, acidic pH range, and basic pH range? Do you know that?
1 to 7 is acid, and then
27.
1 to 6 is acid, and
Hmm?
then
7 is
7 is water, like is neutral water,
neutral, and more than 7?
basic.
Basic. Very good. So if I have one chemical with pH 7 and one chemical with pH 10, which one is more basic?
The pH stuff.
Yes, remember this. And one I have is pH 5 and one I have is pH 2. Which one is more acidic?
The two.
Sorry?
The two ones.
Yes, very good. Remember these points while we are discussing the topics. Now moving on to its properties. First is its bitter taste. Second is its soapy texture. Next is are its reactions. So it is going to react with acid and form the alkalis. Okay. So alkali, they have the same chemical nature. Okay. Now there is a point written. All alkalis are bases, but all bases are not alkalis. Okay. Can you just write this point down? All alkalis are bases, but all bases are not alkalis. And can you tell me why?
Some of them like soap aren't soluble in water, so then they're not alkalis.
Hmm.
And some
Alkalis are usually a subset of base. Just write this point down. Alkalis are subset of bases which are soluble in water. That is what you said. But all bases are not soluble in water. All bases are not soluble in water. That is why they are not alkalis. ठीक है? Clear? Now, then they have talked about the litmus paper. This we will discuss later. We will talk about this later. Now is the neutralization, that also we will take up later. This point, greater pH greater than 7 makes it basic. Done?
yeah.
Quickly tell me the points. The basic nature.
They're better in this. They have a soapy, slippery texture.
Yes, one more.
If they're soluble in water, they're alkalis.
So all alkalis are,
Bases
but all bases.
are not alkalis.
One more. What about the pH?
Yeah. If any liquid has a pH more than 7, it is basic.
Very good. This is what they have shown, that you already know that anything which is acidic will have a pH less than 7 and anything.
What? Lemon has a pH of
Yes.
2?
No, it's not 2 actually. It is the information here is little wrong. It is towards 5. You know what is it, the pH of your blood?
Maybe 4.
Hmm?
Because I have like that because I'm pretty sure it's not that corrosive because it has went into
Okay, also one thing,
high.
you have marble somewhere in your house, marble
No,
top anywhere.
not a border, but it's something like that. The magnets count.
Not
Mag-
magnets. If you have a marble, no. It's if you have a marble, if you rub the marble around the lemon, you will see the color changing and the bubbles on the surface. Okay. Next time, if you somewhere see a marble, try this. And
Blood is basic.
don't tell that your teacher has told you to do. Okay. That's a secret between you and me. Okay.
No, vinegar is almost.
Huh?
Vinegar is
Vinegar is acidic.
like that much acidic.
Where is vinegar, by the way?
It's
Vinegar is acidic. Yes.
like that.
It is around.
Bananas are acidic.
Yes. Bananas are acidic. Bananas are acidic. Milk is acidic. Milk, banana, they are all mild acids.
These are colors from the rainbow.
Whenever you have acidity, doctor never will ask you to eat banana. If you ever have acidity, doctors will tell avoid banana.
And lemon and apples.
Lemon,
No,
apple,
tomato. Why is tomato acidic?
because they have citric, they are also citrus in taste. Yes. Tomato is also acid. Apple, anything which has a sour taste. If you go and taste an apple, that is not a sweet.
Apple, banana, and tomato are citrus fruits. Yes, yet they don't taste
Banana
the
is not citrus. Banana is not citrus.
same.
Apple have a little citric taste. There's so many. I was telling you, you will be amazed to see so many acids we consume. Moving on. Now, here are some of the commonly used bases in our home. Lime water,
Then lime juice.
lime juice, and lime water is different.
Mhm.
Lime juice is lemon water, right? This lime is different. This lime, you might have seen your home getting whitewashed. That
That
lime.
already happened 2 times.
We call it as slaked lime. Okay, the white color powder. That is calcium hydroxide. Next, we use them for cleaning windows also. We use ammonium hydroxide. In soap, we have NaOH, sodium hydroxide, then potassium hydroxide. Sodium hydroxide and potassium hydroxide are main ingredients of your soap and the detergents. Milk of magnesia is magnesium hydroxide. Whenever you have acidity, we consume it. We will know about milk of magnesia a little more later in the same slide. Clear? Chalo. Moving on to the classification, as acids, they are also classified as weak bases and small bases. And then a certain examples are being given of weak bases. Weak bases includes potassium and ammonium carbonates as well as hydroxides. Clear? Strong bases have barium hydroxide, calcium hydroxide. Clear? Just you have to go through the examples, and if you can avoid using these learning these examples, just learn your NCRT examples. Very, very important. Moving on to salts. First, how is a salt formed? A salt is a product of new neutralization reaction. Whenever a acid and a base it react, it forms the salt. Okay? Clear? And since in our environment, so many neutralization reactions are formed, so the main source of salt is our Earth's crust. Salts are usually soluble in water. That is one of their basic nature. Clear? Their basic source you will find in the oceans. Gandhiji did salt march.
Dandi March, right?
Yes, that the whole march was for salt only, na? So the main source of salt is our oceans. But again, you cannot have a ocean salt. You have to first purify it. Clear? Now see, that is what is written. Seawater contains salts such as chlorides, bromides, iodides, sulfates of sodium, potassium, magnesium, and calcium. So all these bromides, iodides, chlorides, they all are salts. Okay? Zinc chloride, salt. Zinc bromide, salt. Barium chloride, salt. So remember, any kind of chloride, bromide, iodide are salts. Can you write it down in your copy? Chlorides, bromides, iodides are salt. Along with sulfate. One more, sulfate. Calcium sulfate is a salt. Yes. So remember, you have to remember this chloride, bromide. If you see anywhere, understand that they are salt. Now, moving on to its pH, you already know since they are formed as a product of neutralization reaction, their pH is going to be 7, neutral. Okay? And I've already told that they are soluble in water. Moving on to the indicators. The indicator is, what do we call the indicator?
Also anything.
Hmm? pH indicator. Yes. pH indicator.
Universe.
Sorry.
I cannot think now.
Now, what do they indicate? How do they indicate? Sorry. How do they indicate?
How strong or weak,
They'll change their.
how basic or liquid is basic or acidic, and how strong or weak it is.
Yes, but how do they indicate that?
Using by reacting to them,
By changing its color,
color.
right? Now there are certain types of uh, these indicators who don't change their color, who can change their smell as well.
Onion indicator.
Yes, onion. You are right. Okay, so we will now understand the categories of it. Natural indicators, olfactory indicators, and synthetic indicators. Natural indicators are turmeric, China rose, and litmus. And olfactory indicators are what is olfactory? Smell related. Anything which is related to smell, that is olfactory. Okay. So when anything changes its smell and indicates that it is acid or base, that those are called the olfactory indicators. And one example is onion. Apart from that, another one is vanilla extract. Okay. Now moving on to synthetic indicators, they are made in laboratories by mixing things. So there are three of them given here: phenolphthalein, methyl orange, and methyl red. Okay. Phenolphthalein is a very commonly used synthetic indicators that you will be using in after grade 10. Grade 11, grade 12, you start using.
I've used it last year.
Huh?
It turns pink when something is
Yes.
basic.
But yes, you're right. So you will be using mostly the phenolphthalein. Now, first we'll talk about the natural indicators. You know that the color of the turmeric is yellow, and what makes it yellow?
Turmeric.
Curcumin, right? It is yellow because of the presence of curcumin. Now, how does it color change? With base, what is
If it touches a liquid, it will turn red if it's basic, and then it will turn yellow if it's acidic.
yes. So when you wash, suppose you have put stain in your white shirt, and when mama washes it, what will be the color change?
Huh?
Suppose you have turmeric stain in your white shirt, and mama adds detergent, and mama washes it. What will be the change in color?
Yellow.
Hmm?
Yellow. I mean red.
Rust red. It will become or dark red in color because soap is basic. Clear? Moving on to China rose. How does it work?
It gives a magenta color in acidic solutions and
And
green
green in?
in basic solutions.
Zamrez, I want you to make a table. Make a table like this. Wait, I'll show you what to do. Yeah. Just make a table like this. Okay. Just write here indicator. Here on the top, write indicator. Indicator. Okay. Then write here acid, base. Clear? Can you do it fast? You did it already.
Okay, do it like on my,
You will do it on your own.
like on word. Just type it down.
I am not able to hear you, Zamrez.
Can I do it on word?
No, you cannot do it on Word. You have to write. You
I'll
have to write
copy
a
it.
test.
I'll copy it down later.
You have to write the test papers, no, Zamrez. You
I'll
have
copy this down later.
okay. Make here turmeric, write here turmeric, China rose. For acid, what should I write here? Zamrez, what should I write here?
Turns yellow,
Yellow, and here with base.
turns red.
Okay. With China rose, what should I write? With acid?
With acid, it turns magenta and then it turns yellow. With
Magenta, and with base?
it turns yellow.
Ah, with base.
Green.
Yeah. Just make a table like this. Done. Now moving on to the next naturally occurring indicator is litmus. And as the name suggests, it is extracted from an organism called lichen.
I'm
About
still
lichen,
doing it, mom.
huh?
Turmeric turns yellow with
With
acid.
yellow, with acid, and with base.
Green.
Okay. Then write about China rose.
China rose turns acids magenta and turns bases green and
Hmm.
then
Litmus.
litmus.
When you're writing litmus, under bracket, write down extracted from lichens. Extracted from lichens. Done. What are lichens? Zamrez, any idea about lichens?
Those things that hang on stones and stuff.
They are sponge. Mhm.
No, not like they hang on like they're like vines, but
Can you Google search lichens fatafat? Fatafat. You will see them on bark of tree. White color. Check fast.
it's like moss.
It's like a moss. Yes, very good. Lichens are formed by lichens are an association. Wait, we'll write it down. Lichens are formed by when algae and fungi stay together, they form a body called lichen. Okay. So whenever there is no, and they are also a pollution indicator, by the way. They are also a pollution indicator. How? They will not grow in places which has a lot of pollution. They grow in less polluted places. So now you will not find lichen much.
Litmus paper is one of the most surprising natural indicators.
Who?
Litmus, like this blue litmus paper, red litmus paper. It looks,
Yes.
it looks so synthetic.
Yes. So now these you're clear about lichens. Lichens are a biological entity that is formed by association of algae and fungi. and the lichen will never grow on a polluted places. They are a polluted, they are a pollution indicators.
What
Hmm?
else? Are there two kinds of litmus paper, blue litmus paper and red
That is
litmus paper?
litmus paper. I'm talking about lichens here.
I was reading this like
First, you have to listen to me, Zamrez, or else I could read the slide as well, right? Now, now, as you just said that these litmus paper in natural environment are violet in color. So if something neutral falls on it, water or something, it will not change its color. It is going to remain violet. But with acid, it becomes pink. And with base, it becomes dark blue. Write it down in your table. Litmus, acid, pink, base, dark blue. Done? Done?
yes.
Now, how are they found in market? They are found in the form of papers, litmus paper. Apart from that, litmus solution. Or in drops also they are found. You can suppose you have a litmus solution. You can put one drop of litmus in your solution and shake your solution to find its pH. Clear? Done? Moving on to next. Olfactory indicators. They again are another kind of natural indicators in case of onion. Remember, be it any kind of olfactory indicator, there's one thing common. With acid, they will retain its smell. But if you put a base on it, it will lose its smell. Okay? Be it vanilla, be it onion, be it anything, be it any kind of olfactory indicator, they have just one character. With acid, they retain smell. With base, they tend to lose it. Just note it down in your point.
Okay.
Done? Now moving on to synthetic one, methyl orange and phenolphthalein. Note this table down. Methyl orange will turn yellow in basic. Methyl orange will turn yellow in basic and pink with acid. ठीक है? Phenolphthalein will change its color due to base. It will turn pink in basic and it will remain colorless if the solution is acid.
Kind of phenolphthalein.
Sorry?
I think phenolphthalein. Phenol.
Phenolphthalein, yes. And what is the natural color of a phenolphthalein? What is a natural color? Do you know? Natural
It's
color is
white.
also
It's
colorless. It's colorless.
doesn't colorless mean it's white?
White is also a color.
It's,
What you're wearing is also a color, right?
this is, no, this is not a color. Well, gray is the color. Black and white are not colors.
White is a color. Anything transparent is colorless. Done? Moving ahead. Nothing much to discuss here. Moving on to the neutral
Just
effect.
such colorless white drawings, white stuff just come up, paper comes up.
See, anything when you can see anything, any color, when you can see anything, it is because it has a color. When you cannot, like, suppose I show you this. This does not have a color.
School says that when school does
School will
that.
say something else when you will grow up. Okay. I'm giving you a little higher order knowledge here. Moving ahead. Neutral effect. The neutral effect or a neutral substance is formed when an acid and a base reacts. That is not coming here. So neutral things will have no effect on litmus, right? Now, suppose you have a litmus paper which is blue. Okay. And you are adding acid to it. What will be the color change? Will there be any color change?
It will turn to red and there'll be no.
It will turn to red, yes. Now you have the red litmus paper, again you are putting it in water.
Turn the base to blue.
It will turn to blue. It has acid in it, you are putting it in water. Water is neutral.
Oh, okay, nothing, no, nothing.
It will have no effect on the color. Okay. Clear? Moving on to the neutralization reaction. Neutralization reaction is the reaction between acid and the base that forms salt and water. Okay. So what is neutralization? It is a chemical reaction between acid and base to produce water and salt. And this is an exothermic reaction. You know about exothermic reaction?
Yes.
So it's exothermic reaction.
Reactions which release more heat.
So when you hold a vessel, which is if you can see in the diagram that acid and a base is reacted. If you hold the surface will be hot. Okay. Now moving on to the implications of neutralization reaction. We were talking about acidity a few minutes back, right? How to solve the problem of acidity?
By eating or by drinking or eating.
By drinking
By
milk of
eating
antacids.
There are also some tablets which are bases.
Yes, yes, yes. Either tablets or by drinking and antacids. What is the composition of any kind of antacid?
What is milk of magnesium?
Magnesium hydroxide.
Milk of magnesium.
Milk of magnesia is magnesium hydroxide, which is a base.
Is it one of those things that
When you consume that, it is going to react with the acid. The acid
it's colorless, right, ma'am?
Yes, it is colorless.
My goodness.
But there are certain milk of magnesias which are pale yellow in color as well, depending on the other bases present.
The thing I used to vomit as a kid when I was having this as a medicine.
Yes. No, now when milk of magnesia goes inside, it is going to work with the HCl of the stomach giving you relief from the acidity.
Not relief from the taste.
No. Moving
Why
on to
did my parents not give one of those tablets?
to you.
Yeah, when I
You
was
should, because you should get cured naturally first. You should allow your immunity to kick in first. Okay. Now, moving on to the next implication, that is the ant bite. You know that ant bite has acid in it, oxalic acid.
Is it tomatoes?
It
Formic acid, right?
huh?
Isn't it formic acid and oxalic
Sorry,
acid?
sorry. I'm so sorry. Yes, it is for formic acid. I'm so sorry. It is formic acid. So when formic acid is going inside your skin, it is going to cause some kind of irritation and redness. Okay? Get a relief. What will you do? What will you do? You will put ointment. Actually, you will scratch.
I will like rub it with my palm.
That will make it more red because your sweaty palms also have acid in it.
I put some water on it.
Washer on it. Uh,
Water.
to get the immediate effect, you can put a little bit of baking soda over it or any kind of base, any kind of ointment that has base in it.
Soap.
Soap, yes, soap you can put, but more than soap, this sodium bicarbonate will be better. Soap will have some, you can put paste. If you have toothpaste, no, toothpaste you can put. Toothpaste is also a very good base. Okay. Now, you can put any kind of lotion that has base in it or baking soda. It is going to neutralize the effect of the formic acid. Clear? Now, moving on to the next implication, I think it is for the farmers. Yes, soil treatment. Now, we were talking about it that acid rain have so much of effect on soil. It changes the pH. Same is that of fertilizers also have a very bad effect on soil. Fertilizers also, when you use fertilizers for a long period of time, they too change the pH of the soil.
Aren't there like other farming methods like following?
Sorry?
Following.
Yes. So what will that do?
It's basically having a break from planting with the same farmland so
Yes,
that I
you can
can.
do that, but if you have to earn money, you cannot take a break. Farmers are not usually very rich, right? They need money, correct?
Yes.
So what do they need to do? They need a quick solution. So they are going to add lime powder in it. Lime powder matlab slaked lime, not lemon. They'll put the white powder, white lime powder on the soil so that the acidity that has accumulated in the soil will be reduced. Clear? And there are so many types of other bases also that you can use. But immediately when you use base in your soil, it will form a neutral soil that is best for plant growth. Now there is one more situation. We do shampoo, right? If we put shampoo, if you take, when you wash your hair after doing shampoo, you can collect the water and put it in your garden plants. They'll die. So pH, be it acid, be it base, anything over is going to affect the health of the plant. So when too much basicity is there, then what you are going to do? You are going to add compost, because compost will release acid. in the soil. Because in compost, there are a lot of microorganisms. The microorganisms will release acid, and due to that acid, the soil will become neutral. Clear? Now moving on to factory waste. This is also a very normal phenomena that we were discussing, that anything that comes out of factory should be treated. Now, factory waste have a lot of acid component in it. Now, if they are not being put into the neutralization tank, you can see here that an alkaline agent is used in the neutralization tank, and it works with the factory acids. It neutralizes the factory waste, and then it is ready to be dumped in the nearby water bodies. If not, it is going to affect the life of the marine. Clear? Any more doubts? And yes, I have a good news that the chapter is over.
For ending the class.
No, we'll do a few question answers for you. I have a few questions. Fatafat.
The chemical nature of acid is acidic.
Very good. Next, sorry. Next is here.
Baking soda.
Very good.
Turmeric.
Very good.
Blue.
Very good. Next.
Calcium hydrox. Wait. Calcium hydrox.
Is it calcium or ammonium?
Ammonium.
Sure.
Yes.
Next.
An acidic solution. Blue litmus paper turns red. B.
Blue litmus paper turns red. Yes. Next.
Acidic solutions into B.
B. Next.
Nitric acid.
Yes.
Sodium hydroxide.
Hydroxide. Very good. Okay, now moving on to a few instructions, Zamrez. After this class, you will be receiving a homework worksheet. Okay, that you have to solve. Along with that, you will be getting a mock test link. You have to do a mock test. Sorry?
There'll be a mail, right?
Not mail. I think they have instructed you in the first class, right? You have to enter and give a test. So you have to do a mock test before the next class, and you have to do a homework worksheet that I'll be sharing. Okay, next class we will be discussing that along with another worksheet. Clear? Okay.
So, bye.
Tell me. Acha, you want to say bye? The favorite part of the day, right? Bye, Zamrez.
Bye, ma'am. Thank you, ma'am. No, it's actually a good morning. Good afternoon.
No, not noon yet. Morning.
Good. Thank you, ma'am.
Bye-bye.
Mm.